Hi everyone. I'm just going to solve one question from control system, and the topic is root locus. Okay, where you have to find the value of k. Okay, at breakaway point. Okay, let me show you the question here. So this question was asked in GATE 2020 in instrumentation paper, and I recommend everyone, those who are from electrical engineering or electronics, if you want to practice control system question, so you guys can practice from instrumentation paper, because many good questions are already have been asked in control system, right, in instrumentation paper, right. So the loop transfer function of the negative feedback system is given by this, okay, where k shall be positive, right, strictly positive. You can see here the value of k at the breakaway point of the root locus for the above system is. So you know that there is a conventional approach that we can follow, that you have to just find the characteristic equation, then you just find k in terms of s, okay, and then you have to differentiate. That is the conventional approach, okay. But I'm not going to solve this question using conventional approach, that the regular approach that we know, because if we are going to differentiate this and solve the quadratic equation, then we will find some value of s, then we have to find out the valid breakaway point and all, right. So what we can do here is we can quickly draw the root locus, okay. So at least pole zero plot, right. So let's say that this is as plane, and here we have got s equal to 0, s equal to -2, s equal to -6. Okay, so these are the poles we have got. One pole is here, one pole is going to be here, and one pole is going to be here, right. So you should be familiar with where the breakaway point might exist, okay, and that breakaway point must be the valid breakaway point. So you know that there, okay, between -2 and 0 there can be one breakaway point, okay, please remember that, okay. Breakaway point might occur between two poles, okay, like when these two poles are there, right, you see between -2 and 0 one, because here can be the root locus segment, okay, between -2 and 0 the root locus segment can exist here, and the root locus segment can exist here also, right. So but between -5 and -2, okay, the breakaway point will not be the valid breakaway point, remember that, okay. So the valid breakaway point will be where the root locus segment is there, right. So between -2 and 0 one root locus segment, okay, and then between minus infinity to -6 you can say, okay. So this is what the story is. Now what we can do here is, instead of going for this approach, like finding k, okay, then differentiating this dk by ds, okay, and equating to 0, and then finding s value, and then plugging s in the k expression, right. What we can do here is, we can find out the midpoint of these, between these 2 points, okay, between -2 and 0, and between minus infinity to -6, okay. uh, in fact between -2 and -6. So as we know that, between -6 and -2, breakaway point cannot exist, okay, that is not the valid okay, valid breakaway point. So what we can do here is, we can just take the midpoint of -2 and -2 and 0. So what is the midpoint of this? The midpoint is going to be here, right. You can say that -2 plus 0 by 2, which is -1, okay. So at this point the breakaway point might exist, understand. I mean to say that as you increase k like this, okay, so your pole is going to meet at this point, and then they will break away, understand. So the midpoint of this -2 and 0, you're going to get -1, okay. So this is the value of s equal to -1, okay, where you can evaluate, okay, this point can be the valid breakaway point. So approximately you can find out now the k value. So I'm just going to consider the transfer function here. So they have given transfer function k by s times s plus 2, s plus 6, okay. So you can just find out the characteristic equation from here, right. So it will be nothing but k plus s into s plus 2, okay, s plus 6 equal, okay, and then you can equate to 0 here, okay, because that is 1 plus GSHS equal to 0. Understand? Now what you can do here is you can plug here, you can evaluate this k, okay, at -1, right? Because -1 is going to be the approximate, you can say, the breakaway point. So minus times, s plus 2, s plus 6, minus times -1 into, s plus 2, that is -1 plus 2 is 1 only, and then -1, that is 5. So this will give you approximately 5. Okay, so answer for this question is going to be 5.0, right? Understand? So this question can be done, within, you can say, 1 minute. It's not a difficult question, but what you guys are going to do here is you guys will differentiate this guy, okay, after finding characteristic equation of this kind. You will differentiate this, right? Then you have to solve the quadratic equation, right? Then you have to find the s value, and you're going to waste your time, okay? So the natural approach that I told you is very important, okay? So you can determine the value of k at the breakaway point using some conceptual shortcuts, right? Without differentiation, and just by exploiting the symmetry and the properties of root locus, okay? So I'm just using the properties of root locus. So as you can see in the question, okay, that what is given, okay, the root locus of the given system starts from the poles, okay, like s equal to 0, s equal to -2, s equal to -3, okay, since we have got the open loop transfer function, okay, and they have these kind of a pole, right? So breakaway point occurs between two poles, or you can say that you know between two poles, remember, or you can say poles and zeros on the real axis. Understand? So for real axis, the root locus lie between two closest poles. Okay, those poles would be very close to each other. Understand? So we have got 0, -2, and -6. Okay, these are the poles. Okay. So we can go for we can find the midpoint, okay, between 0 and -2, we'll get -1, and if you're trying to find the midpoint between -2 and -6, so you are going to get -4, right? But as we know that that is not the root locus segment, okay, where we can't get valid breakaway point. So आपको समझना पड़ेगा, and you will get the answer. So I think this solution is okay, right? You can avoid differentiation. That's what I wanted to explain you. So you can solve any question using this approach. Thank you.